Okay, good afternoon, everyone. Thank you for attending today's presentation on functional testing for lighting controls. The webinar will be recorded and the recording is available to all attendees on the website for the Code Adoption Toolkit. If there are any issues with audio, just feel free to write me in the chat. And my name is Erica Duella, and I'm a project manager for Noresco. This series has been sponsored by the Colorado Energy Office with training materials created by Group 14. And so we've been working with the Colorado Energy Office to provide these trainings over the past year. And this is actually our last one for this series. So hopefully we'll add more. I know Excel is also sponsoring a bunch of trainings, so feel free to check those out too. But if your jurisdiction or if your company is interested in a tailored group training, we are available to do more personalized trainings for your jurisdiction or technical assistance and help with code adoption as well. So, and then along with that, I mentioned the Code Adoption Toolkit previously, and we've been adding a lot of things to that. I know the DOE actually just came out with savings estimate for the 2021 as well. I got an email from them today. So we'll be adding more information, but right now it has information on changing code cycles, what the benefits are, a troubleshooting guide that covers the iCode conflicts, clarifications, and different paths of compliance. And so, as I mentioned, all of these can be accessed through the Colorado Energy Office's website. And then throughout the webinar, we do want to encourage questions. So please use that Q&A function. And I'll let our presenter know at the end. The chat window can also be used. I think Allison might pose some questions to you all, so feel free to use that as well. There is also the option at the end to raise your hand, and I can unmute you and you can ask Allison your question directly. And then lastly, there's that survey window that would be very much appreciated if you take 1 minute of your time to fill that out at the end. So with today's presentation, we have Allison Bagat, and she has over 17 years of experience in building, design, consulting, and commissioning with a specialty in lighting and power systems. She works with teams to optimize equipment, performance, and sequences, and verify that systems are installed in a manner that meets project strategies and the occupant's needs. So she is in good hands today. So I'm going to go ahead and stop sharing my screen, Allison, if you want to go ahead and share yours.
Well, hello. I recognize some of your names in the participant window, so it's fun to see everyone. I'm Allison Bagat. I work for Group 14 Engineering, and these days I commission lighting control systems and power systems. So I'm going to talk today about commissioning these systems. Let's see. I have a little bit of an idea of what kind of work you all do. If you want to write it in the chat, you're welcome to. And then if there's anything you're really hoping to get out of the session, if you know it now, or if you think of something later, please let me know. Okay, oops, I rolled too fast. Here we go. Okay, so I'm going to do a brief review of code requirements. And we're talking about the 2021 IECC code requirements. So they've changed a little bit, and obviously they're not fully adopted yet. Then I'm going to show you what I look for when I'm doing a design review, you know, for lighting control systems. That's what we're going to talk about today. And then I'm going to show you some real pictures of equipment, and we can talk about different nuances with them. Okay. So under the 2021 IECC, automatic shutoff is required for all lighting. At this point, the only exceptions are security, emergency, and egress areas. Everything else is supposed to shut off. And I can't tell you how often I get opinions about whether or not people want things to shut off. I can't enforce code as a commissioning agent, But when I don't see it, sometimes I ask engineers why it isn't there. And if they can't spit out it's for security, emergency, or egress, I really question why it's not there. So the way you can accomplish automatic shutoff is with vacancy sensors, occupancy sensors, or a time schedule, time switch control function that occurs automatically. I would like to point out that under both the vacancy occupancy sensor section and the time switch section, you're required to have a manual switch. Sometimes we don't see those in projects. That can be because we don't want the user group to have access to those switches, but they're supposed to be there. If they're not in the space itself, there needs to be some kind of control screen. Sometimes it's portable, sometimes it's not portable, where you could turn the lights on and off. If it's remote, it needs to tell you how much the light is on. That's really important, and honestly, it helps me out a lot when I'm testing them. When I test, the most problems I find are because of dimming wiring errors or emergency wiring errors. And if I can't turn the lights on and off and ramp them up and down, I have a really hard time telling if it's wired right. Okay, if you pick time switch control or time schedule control, you have to incorporate dimming. And there's different ways you can dim it. If you have questions about that, I'll assume you're checking the code. Automatic daylight control. This is a huge item. It's difficult. I see daylight sensors in areas that don't require them, and I see no daylight sensors in areas that do require them. So somehow this is still a really tough one. They are required when you have more than 150 watts of electric lighting in the primary zone, and now they're also required if we have more than 300 watts in the primary and secondary zone. And that's a change in 2021. Sorry, let me make sure I didn't flip too far. Oh, I forgot to pop up my little new tags. Okay, so the other thing that also changed in 2018 and is continuing in 2021 is aux sensors can have a maximum of 20-minute timeout. It used to be 30 minutes, but now it has to be 20 minutes. Okay, when you're looking at exterior lighting, it has to be off during the day, and then there's special requirements for building facade and landscape lighting. There's also a requirement that general lighting do a 50% reduction after hours. You can pick from these choices. Once in a while, I see designs saying that you can do that with a daylight sensor, and you can't do that with a daylight sensor. You have to have different wiring, or you have to have occupancy sensors. Daylight sensors cannot create a 50% reduction. This reduction used to be 30% in the 2021 codes. It's now 50%. Okay, so if we dig into the weeds a bit more, vacancy sensors versus occupancy sensors. I like to point this out because some devices, if you don't select the correct device up front, you can't change it later. These types of occupancy sensors have to be wired differently. If you wire them for vacancy sensing, you do this solution with a momentary contact switch. If you wire it for occupancy sensing, you have a line voltage switch. So you cannot change this later in the field. I think it's really important that people use symbols that say it's a vacancy sensor. If in one place it's called an occupancy sensor and then it's got a little subnote somewhere saying it's a vacancy sensor, the contractors don't know which it really is and they get confused. These are momentary contact or low voltage switches, and they're the kinds of switches you find with vacancy and occupancy sensors. So we talked about it's really important to use different notation. And just to clarify, vacancy mode is manual on, auto off, and occupancy mode is auto on, auto off. The code moved away from language like that, and I think it's kind of hard because it's nice to have a label. If you don't use vacancy mode, you usually have to meet the requirement that you can only turn lighting on to 50% power. That's not 50% dimming, it's 50% power. And the only way to figure that out is to get out a voltmeter and measure power, because your lighting control system cannot tell you power percentage. So it's actually kind of hard to implement that. So most people pick vacancy mode because it's easier to implement. We talked about needing the switch, and we talked about a 20-minute timeout. There is a bullet point under this code that says spaces that are 300 square feet or less require a sensor. So vestibules are usually less than 300 square feet. You might consider putting occupancy sensors in vestibules. The code updates are, I'm popping them up now where they can be found. When we do time switch control, we need a schedule. And I know it's hard to coordinate that, but somebody has to arrange a schedule so that when it's programmed, we can decide when things turn on and off. It's really important. And these are the sections you can find this code in. So one thing I've really bumped into is the IECC functional testing of lighting controls does not ask me to review emergency lighting, but we have a huge interface with emergency lighting. And it's so important that we get that right. So the thing I run into is I come out and commission the lighting control system, but I don't get an opportunity to see how emergency lighting testing went. So I'm hoping that that was reviewed correctly and that whoever looked at emergency lighting understood how the lighting control system interfaced with it. In this type of design that we're looking at right here, this room is on a relay panel. Right now, there is some issues with this picture. The emergency lighting fixture right here is on relay 11. The normal power one right here is on relay 12. But up here we have an emergency designated fixture that's on 12. And you can't, it really should be on relay 11. They got to be grouped together. We also have to break out the groups that are separately controlled by the daylight sensor. And that was a bit of a problem here. This is a daylight sensor right here. It's supposed to be controlling the lighting around these solitubes. And then we have another daylight sensor here that's supposed to control the lights adjacent to the windows. So right now, emergency doesn't have enough relays, or the relays aren't accurately shown. I'll also point out that there should be dimming functionality in this wall station. Okay, so these are my think about these things. The calibration mechanisms now have to be readily accessible. This is hugely important. And so older devices don't meet that, so they've had to be updated. The code writes a lot of requirements, but there's some other things to think about. Is the daylight sensor going to dim to off or dim to low? And that needs to be covered. As of 2021, the system has to be capable of dimming to off. Again, we need a lighting target in the contract document so that the installation team, the programming team, and the commissioning team know what we're trying to target in the space. A target might be 30-foot candles. That needs to be written down somewhere, or nobody knows how much dimming we're supposed to do. It's required to identify where the daylight zone is. Sometimes it's shown and sometimes it's not. But that's really important to understand which fixtures are going to be controlled. And then, are you going to let the user group dim up above the daylight sensor? Can you raise the lights above the daylight sensors? Believe it or not, there are brands that, for some reason, their first mode of operation, if you hit the first button, you can't dim above the daylight sensor, but if you hit the next scenes, you might be able to. Daylight sensors can be finicky. Sometimes they have a hard time maintaining a daylight set point, so you need to understand your system. And once in a while, I see more than one daylight sensor shown in a zone, and they don't work like that. You can't have multiple sensors controlling one zone of lighting. So this is an example of the kind of exercise you should be doing to figure out if a daylight sensor is required. You have to look at the ceiling height. When it's the window fenestration, it's the depth, it's the height of the height of floor to ceiling is the depth of the daylight zone. And then when you have top lighting, like these are solar tubes, it is 0.7 of the ceiling height. And you lay that out. And so like this plan was missing showing the daylight zones, but this is how you figure it out. In this plan, the daylight sensor is sitting right here, and there's another daylight sensor right here. So these are lessons learned. So an engineer can show daylight sensors in their design, but if you don't say who's required to calibrate them, it can be a hot potato. Sometimes the electrical contractor winds up being responsible for calibrating them, and sometimes a factory authorized lighting technician or a programmer is responsible. And obviously the price of the install changes depending on whose responsibility it is. I find when the electrical contractor learns that it's their responsibility, they think it just calibrates out of the box, and they don't realize they have to get out a light meter and get in the software and create a relationship between what the sensor is reading and how much the lights are dimming. So you got to be really clear on what your requirements are so that we have a successful installation. We have a lot of problems getting daylight sensors to work correctly when electricians have to calibrate them. Sometimes it's not even very easy to run the system to calibrate the sensor. And obviously every brand does it different. You can't calibrate sensors till the finishes are finished and furniture is installed. So those are important notes. Exterior lighting, we have a new percentage under the IECC. A lot of people I talk to will put Denver in zone 4. I really feel like it falls in zone 3 because I think you would put Los Angeles or New York in zone 4, and you need to do a reduction for general lighting at night if you're open then. Big picture, I prefer to have the vendor help lay out sensors. I think things go more successfully that way. They can think about the sensor technology that works for the space the best. They can help with coverage and sensor technology. Those are things that are important. These aren't always standard and master spec, and you have to write them in. Okay. Some of the vendors around town will use more than one brand. It can lower their cost. Sometimes you give up system functionality and the owners don't always realize they have more than one brand in their building. So that can be difficult. We're also seeing wireless lighting control systems take hold. I honestly have struggled a lot with them. A lot of times they don't have lit indicator lights because they're trying to save batteries, and it's just really difficult to tell if the sensor is even working. And when you have a huge building with hundreds of devices, it is just a slog to make sure they're all operating correctly. So 2021 IECC is now going to fall in line with ASHRAE, and we're going to have controlled receptacles. So you might have seen them already on ASHRAE projects. We're now going to see them on IECC. I've seen mixed issues with them. I've seen this indicator symbol be a sticker. I don't really think that meets the intent. I think it should be engraved so it's permanent. And then another thing I run into is at least 50% of the receptacles have to be controlled. Is that both plugs or is it one plug? And some of the receptacles that are available have the engraving on one plug. Some of them have them on 2 plugs, and that needs to be coordinated or it's confusing. Here's some stickers that I've seen. These are the ones that are engraved permanently. Okay. So commissioning, how does commissioning help? We check that things are installed per the design and will work for the owner. And at the end of the day, we all want a project that works well for the owner. We all want that. Commissioning and programming are not the same thing. This is one of the brands in town, and their literature talks about a commissioning app, but they typically use it for programming. Commissioning has evolved over time. It used to be that the manufacturers did most of the commissioning, but because of difficulty, you know, it got pulled into the code, and it's usually third party now. So you just need to understand the differences on your project, what's happening with programming and what's happening with commissioning. Another thing that I bump into is the NEC doesn't always align with the IECC Energy Conservation Code. And now and then what I'm bumping into is code inspectors are not enforcing IECC requirements. They feel like they have to enforce NEC because it's a safety issue. And so what I've bumped into a lot is designs may not meet code, and we're struggling to get it enforced. And I can't enforce it. All I can say is that it doesn't meet code, or the installation doesn't comply with code. And so there's a little bit of fallout in that, because the inspector doesn't hear what I know, and I don't hear what the inspector knows. And projects are passing that aren't always compliant. And all I can say is at some point this could get enforced. And if you get all the way to the very end and you didn't install it, what are we going to do? Because that could be really bad for a company. Okay, so it's a quality focused process, right? We want happy occupants. It's important to have people commissioning lighting controls that understand what they're doing, because they've just gotten really complex. So what I want to do now is jump over and look at a design. This design, we'll call it an office building. I'm going to hop around for just a minute so that you can kind of get an idea of what we got. We'll call it an office building, but it's a fancy office building. It has some event seating. It's got classrooms. Okay, so maybe we'll call it a school, not an office building. Okay, so when I reviewed this design, this project had a matrix to give some sequencing, which is fabulous. This engineer likes to have tag types, and then they list what they want to see for the devices. A couple of the things that I noticed was if you have lead, you're going to need to meet controllability requirements. And in this case, I didn't see dimming. So I was worried whether or not we would meet lead. And then, you know, also for lead, is the space considered regularly occupied, because lead will treat those areas differently too. On these occupancy sensors, I didn't see timeouts, so I asked for those to get filled out. And then the daylight sensor column, what I want to see in addition to that we have a daylight zone is what the foot candle target is. And then if we're dimming to low or dimming to off, if you are going to let occupants raise above the dimming target, that's good information to have noted in these schedules. Okay. So if I go back to the plans, when I was looking at exterior lighting, I was wondering, to me, this looks like almost like the decorative Christmas lights that you plug in. And so my question was, how are we controlling it? Do you have a control point? So I see a control note for signage, but I didn't see a control note for these fixtures. And then what we would expect is if this building has any nighttime hours, they'll have to do a reduction at night. They hadn't added in the control notation yet. Okay, if we go to the first floor, we're now on the first floor. We have a main entrance right here, and there's going to be a check-in desk right here. So if there is a check-in desk right here, this would be a great location to have a centralized lighting control panel. So a lot of times they're digital and they're usually hardwired, but you could pull up any zone in the building and you could turn it on and turn it off. If it needs a schedule, you'd be able to see that information. So I'm asking if a touch screen could be added to this area. What I was looking for here is I see some exits and I'm looking for emergency lighting. And right now I don't see emergency lighting at the point of discharge. So I was asking about that. And, you know, to dovetail with that, emergency lighting was still under development on this project. But it's a really important piece of lighting control because every time you have an emergency fixture in a zone, you need an automatic load control relay that's UL 924 listed so that it's forced on in an emergency. And those have to be coordinated. They are a piece of the lighting control system. They're either standalone or they're relays in the lighting control panel. Things I was noticing when I reviewed this, so I can see we have 2 doors, we have 2 exit signs, so the occupancy load is probably above 50, and right now I don't see an emergency designated light. So clearly we would need to have that in this room. Trying to think, let's go. Oh, here is another room where I was asking, do we need a dimmer switch to meet any lead requirements? We've got an occupancy sensor in the room, so that's how we're accomplishing automatic shutoff. Okay, I don't have daylight sensors yet in this design. Oh, we do. Hang on, we got to get there. So this was my big review note about a daylight sensor. So in this classroom, we've got dimming shown on the wall. We've got 3 zones and a daylight sensor graphic was popped here. This graphic is too close to this light, and I can't tell you how often the electrical contractor sticks it right where the engineer showed it. And I know that the designers, we want the vendor to put the symbols in the right place. But in order for that to happen, this symbol would have to be masked and then it would have to be moved. And as a community, we need to work together better to locate these sensors better because it fails very quickly if it's not in the right place. And it's hard to move it at the end of a project. So I would suggest that this daylight sensor move over here. If the graphic sat right here, it would be in between the 2 rows of electric lights, and it would have a nice area to measure of daylight and electric light. That would be a better location for this graphic. So you can see I had a huge note. You also need to understand your brand of daylight sensors. Sometimes they just want to see below them. Sometimes they want to be a certain ways away from the window and they want to see the daylight and the electric light, especially when we have suspended lighting. We don't want them to be too close to the electric light or it just floods them. I want a programmer to calibrate the daylight sensor that works the best. And then we've got to add some parameters. And this layout is missing the daylight zone. Right now, we don't see the daylight zone, and you're required to show that. Those are hard to back check. It's hard for a design reviewer to back check that because now I need either RCPs or I need section views so that I know what the height of the room is and can lay it out in this view. It's hard to do. You might need dimming in this kitchen to meet lead requirements. And then this area is a group area. You know, lead asks that you provide individual control to user occupants. So task lighting is now being regulated by code, and you've got to coordinate it so that it meets code. Okay, I think that was everything I wanted to show in here. I'm gonna check real quick. Okay, there's one question so far. The question is, after commissioning, who is responsible for maintaining the programming? That's the owner. You know, once turnover occurs, the owner is responsible for maintaining the programming. And, you know, periodically you need to check that all this stuff is being maintained. You need to check that daylight sensors are still accurately reading and working. You know, if you have a system with batteries in the devices, if you have battery failure, you're periodically going to need to change batteries. A lot of manufacturers will say they last 10 years. We're finding it's more like 5. You know, what does failure look like in that situation? But it's the owner's system to maintain, and periodically it's helpful to have someone come back and just make sure things are working right. Okay, I want to look at pictures. I hope you guys want to too. So after a design review, we go test in the field and see if the installation meets what was included in the contract documents. And sometimes I wind up in a tough situation. Sometimes I do have scope to do a design review. Sometimes I don't. If I get asked to do just code required commissioning, I don't get a design review. And if I don't get a design review, I can't verify that the design actually meets code. If it doesn't meet code, I might be commissioning to the contract documents, not what's actually required to be installed. So these are different pictures from out in the field. These are occupancy sensors. There are different brands and they all have different nuances. This guy right here used to be my nemesis because these are indicator lights, but in this brand, they don't light up unless you have a little remote that lets you put the sensors in test mode. So I could see them in the ceiling, but I couldn't tell if they were working unless I had a fully unoccupied building and could wait for the lighting to time out from the timeout period. Now I have a little remote that has a test button, and when I push the test button, these LEDs light up and it shortens the timeout period, and I can check it a lot easier. So it's a little easier to check if the building is still a little bit occupied. Otherwise, you can't check aux sensors if the building's occupied because you can't observe timeout. This occupancy sensor is in a terrible place. This vent is way too close. Most manufacturers will tell you that PIR and dual tech sensors should be at least 6 feet away from vents. That's hard to do in a private office. But if we don't get it further away, they don't work right. And what will happen here is the air can blow on this sensor and cause it to appear like the room's occupied, and it's not. Revit, when you're making a Revit model with your design, you can turn on the work set for HVAC and you can turn on the work set for lighting control. And it's so helpful if these sensors get moved 6 feet away. If we just assume that the electrical contractor is going to take care of that during install because we put a note on the shop drawings that says, please put them 6 feet apart, it doesn't usually happen. And so everyone waits for me to show up and tell them if the daylight sensors or if the occupancy sensors are false triggering or not. Sometimes that's hard for me to tell. This is a different brand of aux sensor. It's shown here in the ceiling. These items are tiny. They're like 4-inch squares or circles. And so sometimes people get other devices on the ceiling mixed up with them, and it's hard to identify what you're looking at. This brand has a round version and now a square version. This was the first time I'd seen the square version. And what I'm showing you is there's an indicator light in here. So I look to see that the occupancy sensor is physically located in the ceiling, but then I also check if it's powered. There's actually 2 LED lights in here. One of them is a low level LED light, and then there's a bright one. And as you move around the room, it flashes to show the movement. And I look to make sure that that's how the occupancy sensors are responding. This sensor also has an LED indicator light under the lens. If they're battery powered, they don't turn them on. They don't want to waste the battery. So you have this sensor in the ceiling and somebody has to decide, did it get placed there? Is it actually wired? Is it working? Okay, this is a daylight sensor. This teeny tiny little dot up there is a daylight sensor. These are not lights, these are decorations. They're pieces of acrylic. When I looked at this room, I said, wow, we're just not daylight dimming very much. I think we could do more. But you do run into a balance point between owners wanting a certain level of aesthetics versus energy savings. So that's something we bump into when we're evaluating if we are daylight dimming correctly. In this room, this is, in my opinion, a bit of a sad room. We don't have very much daylight. This daylight sensor wasn't actually required because the requirement is that you have 150 watts of electric lighting in the daylight zone. Well, if you look at the code, the daylight zone extends 2 feet on either side of the window. So this is a daylight zone. And this is a daylight zone. And we just don't have 150 watts in each of those areas. But we paid and installed and programmed daylight dimming that's just not going to dim much. This sensor is in an interesting location. It's not too close to the electric light, but it's also kind of up against this wall. I would rather see it spaced in between these 2 rows, but whether or not it's ever going to have a very good view of daylight is really questionable. In this project, the daylight sensor is too close to the light. It's going to read a lot of daylight, and that's going to be a problem too. Or I'm sorry, it's going to read a lot of electric light, and that's also going to be a problem because it's going to have a hard time balancing the daylight that's over here. In this room is so daylit that even though the shades are down, the lights are dimmed to low. The daylight sensor sitting right here. In this brand, the daylight sensor looks very similar to the aux sensor, and the only difference is the daylight sensor has a flat lens, and the aux sensor has a Fresnel lens that's got contours. So that's how you know the difference between their daylight sensor and their occupancy sensor. But this is good, right? The lights are dimming. We have plenty of daylight. This is like your standard cubicle office building. We have a daylight sensor over here. Again, it's so daylit, even though the shades are down, that the lights in the daylight zone are at a minimum dim level. What was interesting about this building was these are kind of bright too. And what would have been nice is to apply an upper threshold to kind of take them down a little bit, because there's still plenty of daylight, even though we're way back in the space. And prescriptively, we don't need a daylight zone anymore. This was designed under an earlier code. If it were under 2021, this light fixture might have been part of a secondary daylight zone. Okay. I don't know if you've been out to the airport lately. I've been working on the West concourse, and it's been fun to see daylight dimming get implemented out there. This side of the building is the south facade, so we have a lot of dimming occurring in the daylight zone there. This row of lights is actually controlled with the lighting in the popped up part of the ceiling, and so they're dimming based on a daylight sensor that's located in this area. And then this row again is associated with that center zone. And this is the north facade. So we were having a little bit of a problem where the north facade wasn't dimming, even though there was adequate daylight. It just takes some time to calibrate the relationship between the daylight sensor and the amount of daylight that's measured on the work plane. And so you can change that, and that will cause the zone to dim more. Those are important steps, or we don't wind up with daylight control enabled correctly. This is one of my wireless lighting control projects. I am so sad about this switch. This building was an existing building, but it seems like it would have made more sense to install it over here by the store, because being behind a door is not very helpful. I was told that the likelihood of this door being propped is low, propped open, but these switches are just hard to get to. This is a wireless occupancy sensor. So when you look at it, you can't tell if it's on and if it's associated. The only way associated with the lights, the only way I can do that is to use, I either turn on all the lights and leave and wait for the timeout and make sure they turn off, or through an app, I can flash the zones. I might be able to dim the zones. And that is one of the only ways that's really easy to test it. The other way you can test this particular device is if you have a fancy green laser. There's a teeny tiny hole in the bottom, and I can activate the device by shining this laser in the hole. It's kind of hard to get it lined up correctly. So sometimes I think when we're picking these products, we don't realize how hard it is later to verify that they're really working. On this job, you know, I don't know if this manufacturer would call this a networked lighting control system. In my opinion, it's not. It's very much standalone. Even though I have a fancy app on my phone to control things with, you have to go stand in every room and toggle everything to see how it's going to sequence. So it takes a lot of time. I wanted to show some pictures of different products. Some of you are probably very familiar, but the user experience can be really different. And then the programming can be really different. I think this switch can be programmed a variety of ways. So the way this indicator light lights up can vary depending on what you pick for programming. Usually they seem to light up when they see you, or when they hear things. They do hear. So then I'm trying to make sure they're hearing human sounds and responding correctly, and not responding to the HVAC that might be rumbling nearby. On this device, this is an on-off button. On this device, this is the on-off button, and they look really different. Sometimes I'll show you a different picture later. Sometimes the location of these items are switched around on them. These are dimmer switches in 3 different brands, and look how different they are. You know, these are in a vertical pattern, these are in a sideways pattern, and the experience is totally different. In this brand, the sensor is above the buttons, and in these brands, the sensor's below. These are different types of wall switches you can find. Scene switches can change the lights in different zones to different light levels. This is a channel switch. They're kind of my nemesis. Right now, 1 and 4 are lit. So if I dim up, whatever is controlled by 1 and 4, which in this case we had a lovely sign added, will be adjusted by the up button, but 2 and 3 won't be adjusted. So I have to select all 4 of them if I want to turn them off or on, or dim them up or dim them down. Otherwise, I just select one individually to control it. It's kind of confusing for a user. A scene switch will at least make some of those programming adjustments automatically in the background. This light switch can control 2 zones of light. You know, you have an on and an off and an on and an off. Now, what are you controlling? I don't know. You're going to have to toggle them in order to see what they control. This switch I've struggled with a little bit. It is a super cool switch. It has so much functionality, but it has so much functionality that if you encounter it in the field and nothing's labeled, you don't really know how it works. And then the other problem is these buttons are small, so they can't fit very many characters on them in terms of a name. So how do you pick a really short name that tells you how it works? These are some other brands that you might encounter. We're now supposed to label the switches, and we run into some different strategies on that because it's hard if the owner changes things later. Obviously, some names can be easier to understand than others. This dimmer switch will tell you how much light is coming out of the fixture. This is a different brand of lighting control switches. Supposedly these are hospital grade, but a year after they were installed, they were starting to pop out. It was also interesting, you couldn't get an up arrow or a down arrow, so they had to write raise all or lower all. And the problem with different brands of lighting control systems is trying to coordinate how many junction boxes you need, how many switches you'll have, how many buttons you'll have. And that's why some of these are cover plated over, because the design strategy changed between the contract documents and the shop drawings. And so it affected how many boxes you needed and how many buttons would be on each switch. So it's something to think about. This is a different bank of switches. All 8 of these are sitting next to each other. This is a lot of switches to encounter and to decide how to use and what they really control. And again, raise and lower were written on the buttons because an arrow wasn't available. So here's my picture on controlled receptacles. In this case, the top and the bottom are actually controlled in this installation. But right now it's only printed on the bottom one because that's what the contractor was able to order. In talking to the contractor about these, it was really hard for them to order these. They're thinking about, can they plug the wiring in instead of having to bend the wires around the screws that are the terminals on the receptacle. They needed some of the receptacles to be GFI protected. It was hard to work out this controlled receptacle piece. So you might need to think about it if you have different situations, and even work with your electrical contractor. Okay, I think we got to the end of all my material. So I'm happy to take questions if we have questions.
Great, thanks, Allison. We've got one question in the chat. Are MEP rooms still exempt from automatic controls?
They are. And I think they're actually starting to clarify it better in the 2021 code. I think I've seen mechanical and electrical room written down in the IECC, which is great because that's clear. It used to be you had to know that the NEC trumped the IECC on that requirement. Yeah, Mike, you and I have talked about the daylight zone problem. So, and I did have one more thing if we want to talk about it, but so we're noticing, so I have also looked at this because Mike has talked to me about this before. For some reason in the side light diagrams, they're saying it's 2 feet on either side of the window. But in some of the other diagrams, they're using a different formula to determine the width. So I don't know if this will get streamlined or not. Shauna did a presentation on the 2021 code changes a few weeks ago, and she was kind of poking at some of those items too. So the one other thing, and if you have more questions, let us know. But I'll talk about one more thing if we don't have other questions.
We have one other question before you jump in, Allison.
Sure.
Are wireless systems easier to work with across brands?
I guess I don't know what you mean by across brands. Different brands have wireless lighting control systems. They're very different, and you need to ask. I think we might make the mistake of assuming they're fully networked, and I'm not sure that that's true. I have seen a few vendors in town say, okay, let's compromise. We'll wire the occupancy sensors in the room. That way we get better coverage, we get better, we don't have batteries, and we'll do wireless daylight sensors and wireless wall switches. That is an okay compromise, but most of those systems I don't think show a lot of information in the software, and so I'm struggling to test them. Okay, are there any other questions at the moment?
Not at the moment.
Okay, and I'll run through one more thing. Under the 2021 IECC, we're now being asked to limit open office areas to 600 square feet of control. This is another one that's really hard to back check. At first I went, oh, we don't have 600 square foot zones shown. And then I did start to realize that these are located so that we are getting 600 square feet of control. How do we back check that? Now we're doing area takeoffs to make sure that we got 600 square feet of coverage covered. The other thing I noticed about this particular project is some of the light locations now don't line up very well with the furniture. So if no one's over here and these lights shut off, what's the impact to people over here? And I guess a better example is maybe up here. If I'm sitting right here and nothing is triggering these lights, then I'm hoping I'm triggering these lights. And so it's going to be hard to get good coverage, good lighting coverage with our furniture potentially, and meet these control zone requirements. I think there was also, there was a small error on this one. These 4 fixtures are supposed to be A's. I guess I'm wondering why this D is hanging out here. These 4 fixtures are supposed to be B's. Because I have an emergency light, I either need a UL 924 just for this light, and it's slaved on this zone, right? And that's the way you make it work. In some scenarios, you might need a different relay zone so that you have more control. Another thing I noticed, this fixture matches this sensor, but I think there could be a typo with some of these other letters because we've got a C sensor here and I have C lights over here because this sensor is also C. So it seems like this one was supposed to be E. So those are the type of things I look for when I'm doing design reviews. Okay. Is everyone like bowled over by the amount of information they got?
We do have another.
Is there any?
From Mike.
Oh, go ahead.
If I'm not mistaken, there is now an exemption for open offices to follow time switch controls, which was not an option in 2018.
I have to go remember to answer questions like that. You could be totally correct. The 2021 IECC aligns a lot more with ASHRAE, so there's some kind of big whoppers in there compared to previous versions of the IECC. So it's going to be important to get familiar with them. I was hoping I could find open offices quickly, which might be hard to do. I can't remember where they're at. So that might be something we could talk about offline, Mike.
Yeah, we can follow up. All right, well, I think that's all of the questions we have so far. Allison and I will stay on for another minute or so. If any other hands want to be raised or questions asked in the chat or in the Q&A, we'll hang on. But otherwise, thank you, Allison, for a very informative webinar. I enjoyed the pictures and walking us through all of that. It creates a nice visual.
Pictures are kind of nice. Fun to not stare at plans.
Exactly, yeah, it puts it into real life. So that's appreciated. And thank you to everyone for attending our last webinar of the series. So we hope to kick them back up late summer, but we will keep you posted.